Let's now talk about predicting the spontaneity of a redox reaction. In this problem, we're asked to predict whether or not the following reaction is spontaneous. Cu solid plus 2H plus goes to Cu2 plus H2. So another way of saying that is, if you were to place a piece of solid copper into an acidic solution, will the copper dissolve to make Cu2 plus ions in aqueous solution, and will you produce hydrogen gas? In order to solve this problem, we have to recognize that this problem is telling us what the overall reaction should be. And so we have to now look for half reactions that involve all of these species. We have to look for a half reaction of Cu going to Cu2 plus, and look for a half reaction that involves H plus and H2. And so when you go to the table of standard reduction potentials, you'll find the half reaction for the reduction of Cu2 plus to solid copper, and the half reaction for the reduction of H plus to H2 gas. You're always given these half reactions in their reduction form. Now what we have to do is think about how you can manipulate and rearrange these two half reactions so that they add up to what the goal of the problem is, right? So in our goal, we want to have Cu solid on the left-hand side of the equation. And what we recognize is in the reduction half reactions that we're given, Cu solid is on the right-hand side of the equation. And so this reaction has to be reversed so that we can put Cu solid on the left-hand side. We can go back up to the goal reaction and recognize that we should have 2H plus on the left-hand side. And when we look at the reduction half reactions that we were given, we see that we have 2H plus on the left-hand side. So this is exactly what we want. We're going to keep this one the same so that we have 2H plus on the left. All right, one more thing to keep in mind is when you reverse the half reaction for the Cu2 plus, you have to change the sign of E naught. So we'll maybe add that statement in here. So reverse and change the sign of E naught. All right. So we've now reversed the copper half reaction and changed the signs so that we get negative 0.34 volts, and we've done nothing to the half reaction involving the reduction of H plus to H2 gas. Now what we can do is add up the two half reactions to get the overall, and you get the exact overall reaction that the problem is asking about, right? Cu solid is reacting with H plus ions in solution. That dissolves the copper into Cu2 plus ions in solution and makes hydrogen gas. And we find that the standard cell potential for this reaction is negative 0.34 volts. Now, is this reaction spontaneous, right? So is this reaction going to happen? We can calculate the value of delta G standard in order to find out. So to do that, we have our equation delta G standard equals negative NF E naught for the cell. And so delta G standard is negative. We found the number of moles of electrons here to be 2, because that's the coefficient of E minus. So 2 moles of electrons. Faraday's constant is 96,485 coulombs per mole of electrons. And we found that the standard cell potential was negative 0.34 volts, or that's negative 0.34 joules per coulomb. All right, we can also convert this into kilojoules, so we'll divide both sides by 1,000, because that makes the numbers a little bit easier for us to deal with here. The moles, the coulombs, and the joules cancel out, and I'm left with just units of kilojoules. And what we find is that the value of delta G standard in kilojoules comes out to positive 65.6 kilojoules. Now, because delta G is greater than 0, this process is not spontaneous. And, in fact, anytime E naught for the cell is negative, we're going to deal with a situation and a reaction that is not spontaneous. Because imagine if you plug a negative number in for E naught, the negative sign out in front of the equation cancels it out, making delta G positive, making the process not spontaneous. And so you can safely put a solid piece of copper into an acidic solution and not worry about the copper dissolving. Now let's take a look at another example. You're told that a piece of solid copper is placed into an aqueous solution of iron 2 sulfate. You're asked to determine whether or not solid iron will deposit onto the copper. and you're given some standard reduction potentials that you'll need to think about how to rearrange to give you what the goal of the problem is, and then determine whether or not the process is spontaneous. So take a moment to think that over, to write out the reactions, and to put in what you think the answer is. All right, having given you some time to think it over, let's talk about the answer. This problem is again telling you what the overall reaction should be. So you're told that you want to do the following. You're starting with a solid piece of copper, so that's going to show up on the reactant side of the equation. And you're starting with an aqueous solution of FeSO4. And so that means that the iron is starting off in the form of Fe2+. So we're going to write it as Fe2+ on the reactant side. Now, you're being asked, do you produce Fe solid? So now on the product side of the equation, we'll put Fe solid. We have to predict what the other product of this reaction is. And so we recognize that in this reaction, Fe2+ is being reduced. Fe2+ is gaining electrons. And if something is being reduced, then that means that something else has to be getting oxidized, right? That means that the copper has to be the thing that's getting oxidized here. So the copper will be oxidized, the copper will be losing electrons. And that means that the copper will go to the form of Cu2+ ion. Now, having written out the reaction as specified by the problem, you can think about how these two reduction half reactions can be rearranged. We recognize that you want to have Cu solid on the left-hand side of the equation, and it's not currently, so we have to reverse the copper 2+ reduction half reaction. So this one gets reversed to put Cu on the left, and the half reaction that involves Fe2+ should be kept the same. So for this one, we'll say keep it the same because you want to have Fe2+ on the left. All right, let's go over to the next slide and rewrite the reactions written in the appropriate ways, and also keep in mind that you have to change the sign of E0 for the copper half reaction if you reverse it. All right, so having rearranged and rewritten the reactions, we can now add them up to get what the overall reaction is. And we get exactly what the problem asks us to do. We take a solid piece of copper and we add it to a solution of Fe2+ ions. We're going to make Fe solid, and in the process, Cu2+ gets generated. When you go to calculate the full cell potential at standard conditions, that comes out to negative 0.78 volts. And since the full cell potential at standard conditions is negative, that means this process is not spontaneous. You will not be able to get this to occur. If you wanted to make it happen, you'd have to apply an external current and voltage. Okay, so to summarize and recap some of the different types of problems that we've seen so far in this chapter, and to also get a little bit of experience with writing the reactions for electrochemistry problems, let's talk about the two types of problems that we've discussed so far. The first type is a galvanic cell. And in a problem where you're dealing with a galvanic cell, the question has to use that word. Or it could also use the word voltaic. That is a synonym of galvanic. So if you see the word galvanic or voltaic in a problem, then you're going to approach the problem in the following way. You must write the half reactions in a way to make the standard cell potential positive. That means whichever reaction has the greater value of E0 stays the same, and the reaction that has the lower value of E0 gets reversed. That will guarantee that you get a positive cell potential, and that guarantees that you're writing a spontaneous reaction. When you're dealing with a galvanic cell, you're dealing with whatever reaction spontaneously occurs in your cell. A different type of problem that you could see is one where you're given the overall reaction and you have to predict whether or not it's spontaneous. And so in this type of a question, you will not see the word galvanic included. And the reason for that is because you do not know whether the reaction is spontaneous or not. You don't know whether the cell potential is positive or not. And so for that reason, the question has to tell you how to write the half reactions. The problem will give you what the overall reaction should be. And then you have to arrange the half reactions so that they add up to the overall reaction that the problem has specified for you, right? You're predicting whether this reaction is spontaneous or not by then looking at the value of the standard cell potential. If it's positive, then the reaction is spontaneous. And if it's negative, then the reaction is non-spontaneous. So those are the two different problem types, and they're distinguished by the way that the problem is worded. So when you have a problem that involves a galvanic cell, the problem will include that word, or it'll say voltaic. And if the problem does not involve a galvanic cell and you have to predict if the reaction is spontaneous or not, then the problem will tell you in some way what the reaction is that they're asking you to study.